Hello and welcome back to the Math AA Standard course. This is part 8.2, which is about Venn diagrams and sample space. Again, I do not have any credentials. I'm just going off of what the official IB book says. So I'm quite certain that most of you have seen a Venn diagram before, but if not, you draw a square, a rectangle that is, and this rectangle represents the universal set, so that would be denoted by a U. This is the sample space I was talking about in the previous chapter. So this would include everyone, and then you would put a circle representing two different events or situations. So in this case, I put circle A and circle B, and then the one with the arrow pointing at it is the actual Venn diagram. And there's a section in between the two circles that are connected, which shows the people who are in both situations. The notation for Venn diagrams, or for the probability of certain events, looks like this. So if you have this notation, which is like the upside down, let's say sad face is the intersection. You are looking at when people are partaking in both events. This next one, if there's a little prime in front of one of the letters showing the events, it means not that one. So now you're just saying everybody who does A and not B. So that would be everybody in the A circle, not including the intersection. Now if you put a prime on both of these situations, that would mean that you're looking at the people who are in the rectangle but not in the circles. You're looking at the people who do not do either situation, event, so on and so forth. So if the notation looks like a smiley face instead, it is called the union. The union refers to essentially everybody who is partaking in the events. So that would be the people who only do A, the people who do A and B, and the people who do B. Now, if a prime is added to either situation, that means that you are finding the amount of students who do situation A or do not do situation B. So you are including the intersection still, the people who do both. So you would essentially be finding everybody who does A, the people who do A and B, and the people who do neither. Now, the way I remember it is because it looks like a smiley, you're happy because you're including everyone. Or you're not including everyone, but you're including the intersection, which is something you do not do if there were a prime in the other situation. I like to think of the sad smiley face as an and the happy smiley face as an or. I don't know if that helps. Hopefully it does. So the addition rule is another thing you have to know. This rule essentially states that the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. You would use this in the situation of not having the full Venn diagram and you only have certain information. Then you can use this rule to figure out other parts of the equation. So the next and last part of this chapter is mutually exclusive events. So mutually exclusive refers to situations that cannot happen if the other situation happens. So let's say that let's say you're tossing a coin and you are only allowed to do it once. You can't get both heads and tails. You can only get one. Therefore, getting heads or tails would be a mutually exclusive event. In mutually exclusive events, the Venn diagram would look like two circles that are not touching at all. Now, this would generally mean that the probability of A and B would equal 0, and that the probability of A or B equals the probability of A plus the probability of B. So these are a few ways to know whether or not it is mutually exclusive. Now, time for the quiz. In this Venn diagram, we're looking at the students who take chemistry, biology, neither or both. So there are 3 people who take chemistry, there are 14 people who take biology, and there are 5 people that take both. So question 1 is find the probability of people who take chemistry and biology. B is find the probability of people who take chemistry and not biology. Find the probability of people who take neither, and find the probability of people who take chemistry or biology. Now, question 2 would be, sorry, the quality went really bad because I accidentally made a mistake and had to redo it, so it just looks really bad, is to understand how the addition rule works. So this is a fairly straightforward answer. I gave you what A was, what B was, and what the probability of A and B was. So you can just ignore that really. It's just like showing how the relationship works. Okay, now you can pause and come back because I will be going through the answers right now. There are 5 people that take bio and chemistry, and there are 50 people, so that would be 5 divided by 50, which is simplified to 1 over 10. Now, there are 3 people who take biology, and yeah, so it would be 3 over 50. Now for C, you're looking at the people who do neither, right? So you have to add up the people who do bio, the people who do chemistry, and the people who do both, and then minus that from the total to find out who doesn't do any. So that would be 50 minus 22, which is 28. So 28 over 50, which would be simplified to 14 over 25. So the probability of someone doing neither, if you pick them at random, would be 20. I'm kidding. Would be 14 over 25. Now, the union would be the people who do bio, the people who do both, and the people who do chemistry. As you figured out in the previous question, that is 22. So that would be 22 over 50, which is simplified to 11 over 25. So those are the answers, and obviously the answer to D is the same as the answer to question 2, so I will not be explaining that, but obviously I don't really know why I made question 2. That was sort of pointless because we have the full Venn diagram. The addition rule is really only necessary when you don't have all the information. So thank you for today. That was it. Please feel free to subscribe, like, and comment. Follow me at Johanna Frennert if you feel like it on Instagram. And goodbye. Hope you learned something. And I'll see you tomorrow or in 2 days with the next part of Chapter 8.